Welcome, dear learners. This video introduces Delhi's severe air pollution crisis, focusing on particulate matter, that is PM, and the emerging threat of microplastic contamination. It highlights how Delhi has become one of the most polluted cities in the world, with worsening air quality driven by urbanization, traffic emissions, and poor waste management. Microplastics, often overlooked in air studies, are gaining attention as they mix with particulate matter and aggravate health risks. This overview sets the stage for exploring pollution sources, research findings, health implications, and policy interventions. The goal is to raise awareness and advocate for integrated strategies to address Delhi's unique air quality challenges. Delhi's air pollution is among the highest globally, primarily caused by rapid population growth, uncontrolled urbanization, development, increasing vehicle emissions, industrial activities, and seasonal stubble burning. Particulate matter is a major pollutant with severe health consequences for millions of residents. Recently, researchers have discovered that airborne microplastics further worsen pollution, making air quality management more complex. These pollutants originating from plastic waste, textiles, and industrial processes are now part of Delhi's already toxic environment. This introduction, that is microplastic, emphasizes the need to study air quality beyond traditional pollutants, focusing on the interplay between particulate matter and microplastics to inform more comprehensive solutions. In Delhi, PM2.5 levels averaged 88.4 micrograms per cubic meter in 2023, over 8 times the WHO guidelines. This hazardous concentration significantly reduced life expectancy, with residents losing about 8.2 years of life on average. Nearly half of the Delhi's population lives in the areas that exceed India's own standards for PM2.5, creating a persistent public health emergency. Air quality worsens dramatically during winters due to stubble burning and stagnant weather conditions, often reaching severe or hazardous levels. These alarming figures highlight a growing health burden, particularly for vulnerable populations, and demonstrate the urgent need for stronger pollution control, sustainable urban planning, and public health measures. Talking about the particulate matter, it refers to a tiny particles suspended in the air classified by the size, that is particulate matter 10, which sizes less than 10 or equivalent to 10 micrometer, particulate 2.5, that is less than or equivalent to 2.5 micrometer, and particulate matter 1, equivalent or less than 1 micrometer. PM2.5 and PM1 are particularly harmful as they penetrate deep into the lungs and can enter the bloodstream. In Delhi, major PM sources include vehicle exhaust, construction activities, industrial emissions, biomass burning, and atmospheric chemical reactions. These particulates remain suspended for a long period, contributing to smog and respiratory illness. Understanding PM size distribution and origin is essential for designing targeted pollution control strategies. Microplastics, defined as a plastic particles smaller than 5 millimeter are growing environmental threat traditionally studied in oceans but now increasingly found in urban areas like in Delhi in the atmosphere. They originate from degraded plastics, textile fibers, industrial processes, and waste mismanagement. Microplastics in the air can absorb toxic chemicals and heavy metals, acting as a carrier for pollutants deep into human respiratory system. Inhalation of these particles pose unknown long-term health risks, adding a new dimension to air quality challenges in cities like Delhi. Research studies in Delhi have revealed concerning levels of airborne plastics with PM10 samplers average 1.87 microplastics per cubic meter and detectable level also present in PM2.5 and PM1 fractions. Seasonal variations show higher counts during pollution peaks, particularly in dry and dusty months. The morphology of these microplastics is dominated by fragments, that is 66%, fibers 32%, and mostly between 1 to 1000 micrometer. These findings suggest that microplastics are not only widespread but also closely linked to pollution episodes. Understanding their size, composition, and seasonal distribution is crucial for developing mitigation strategies and highlights how urban air pollution has evolved into a more complex and multi-pollutant issue. Airborne plastics in Delhi primarily consists of polyethylene tetrafolate (PET) and polyethylene (PE) materials commonly used in packaging and textiles. These polymers are often accompanied by trace metals such as zinc, silicon, and aluminum, intensifying their potential toxicity. The presence of metals highlights how microplastics act as chemical carriers, making their inhalation especially concern for human health. Sources include burning of plastic waste, industrial emissions, and abrasion of synthetic materials. Street dust analysis shows microplastic concentration ranging from 18.88 to 116.66 microplastics per 100 gram, with the highest levels observed in summer post-monsoon. Busy roads and landfill areas show especially high concentration due to heavy traffic, poor waste management, and accumulation of plastic debris. Microplastics in dust often adhere to larger particles, enabling their spread through wind and increased inhalation risks. These findings underline the importance of dust management and the role of street-level pollution in overall air quality. In case of Delhi, microplastic originate from multiple sources, include tire and road wear, textile shedding, improper plastic waste disposal, and open burning. Wind studies reveal that microplastics travel predominantly from northwest towards urban areas, influenced by meteorological conditions. These particles undergo weathering and alter their surface chemistry and enhancing their interaction with other pollutants. The atmospheric transport of microplastics underscores the microplastic pollution is not only a localized issue but a regional challenge influenced by environmental and urban planning factors. Exposure to PM2.5 and microplastics poses significant health risks as these plastics penetrate deep into lungs, tissue, and can enter the bloodstream. Microplastics often carrying toxic chemicals may trigger oxidative stress, inflammation, and respiratory illness, while also being linked to cardiovascular problems and potential carcinogenic effects. Vulnerable groups include children, elderly individuals, and those with pre-existing respiratory or cardiac conditions. The combination or combined presence of the fine particulate matter and microplastic magnifies public health challenges, making Delhi's air quality crisis particularly alarming. Research has confirmed the presence of microplastic in groundwater also across all 11 districts of Delhi, revealing a widespread contamination problem. These particles can infiltrate soil, water system, and agriculture produce, entering the food chain and increasing human exposure through ingestion. Over time, this exposure may cause systematic toxicity, compounding risks already posing airborne plastics. Delhi's PM2.5 levels remain dangerously high, fluctuating between 80 to 90 micrograms per cubic meter annually, with significant seasonal spikes between November and February. These peaks are largely attributed to agriculture, stubble burning, industrial emissions, and unfavorable conditions that trap pollutants, while policies like the Graded Response Action Plan (GRAP) and traffic restrictions have yielded localized improvements. Overall, pollution levels remain far above safe threshold. Last year, November 18, 2024, Delhi's air quality index reached an alarming 491, that is severe plus, driven by stubble burning, low wind speeds, and temperature inversions, which trapped pollutants near the ground. Such extreme events result in spikes in hospital admissions for respiratory and cardiovascular illness, overwhelming healthcare infrastructure. These studies highlighted the urgency of proactive pollutant management rather than reactive measures. By analyzing these episodes, policymakers can better anticipate pollution strategies and implement preventive strategies. Delhi has implemented initiatives like GRAB, widespread air quality monitoring, and promotion of electric vehicles to tackle pollution. Polluting industries have been closed, while public awareness campaigns aim to reduce waste and plastic use. Non-governmental organizations and citizen-led movements are playing a key role in waste segregation and community-driven cleanup efforts. However, enforcement challenges, gaps in microplastic monitoring, and poor waste management limit this success. Talking about the research initiatives, IIT Delhi and partner institutes are leading research to study particulate and microplastic pollution in urban area of the Delhi. Using mobile air pollution laboratories, researchers are analyzing chemicals and plastic composites in PM2.5 across industrial and traffic-heavy areas. Their findings indicate that plastics form a significant part of Delhi's airborne pollutants, emphasizing the need of target control measures. Ongoing projects are also focusing on improved air sample technology, quantifying microplastics, and assessing their health impacts. Microplastics are extremely difficult to measure due to their microscopic size, varied shapes, and chemical diversity. Delhi currently lacks a regulatory framework or standards for monitoring microplastic in air and dust, creating a major gap. Additionally, scientific understanding of the long-term health risks and effective removal technologies are remaining limited. Addressing these challenges will require significant investments in research, monitoring, and infrastructure, and interdisciplinary collaboration. The future strategies must integrate microplastic monitoring into the air quality standard alongside of PM measurement. Reducing plastic waste, improving recycling system, and enforcing ban on single-use plastics are critical first steps. Additionally, policymakers need to focus on sustainable urban design, clean energy adoption, and industrial emission control to reduce pollution at its source. Call for action. Delhi's air quality crisis call for immediate collaborative action. Citizens must commit to reduce plastic consumption, supporting sustainable waste management, and advocating for clean air policies. Governments need to enforce strict emission control, invest in air quality monitoring, and incorporate microplastics into environmental regulations. Collaboration between industries, researchers, and communities will be essential in addressing this challenge. Finally, I thank the audience for their kind attention and encouraging them to reflect on urgency of Delhi's air pollution challenge. It serves as a transition to discuss questions and action-oriented planning. The overreaching goal of this video was to raise awareness about intermittent threats of particulate matter and microplastic pollution, inspiring collaborations, solutions, promote public engagement. By understanding the science and the real world impact presented, participants are empowered to advocate for stronger environmental policies and take individual steps to reduce the pollution, making Delhi's future safe and more sustainable. If you like this video, please don't forget to subscribe, like, and share. Thank you.